Hello, everyone. I am Alan Willard, as it will say across the bottom somewhere, Senior Developer Relations Technical Artist. I was asked if I could make my title shorter. Instead, I tried to get him to expand it, type out the word senior. He wouldn't do it. So what I'm going to be talking about today is creating complex effects. And what that means is not necessarily a really dense particle system or something like that, but rather using multiple systems together to create one that is greater, hopefully, than the sum of its parts. I started off just wanting to create an environmental effect, just being able to look through like a sheet of glass and seeing an electrical generator that was arcing kind of out of control. And I wanted to make it something that level artists and designers could easily tweak to the situation without having to reinvent it or go into the blueprint and modify settings or create a duplicate, things like that. So what I decided to do was create something that was really parameterized and leveraged the ability for particle systems, blueprints, materials, lights to all communicate with each other and pass those settings around. So if we look at the level here, I've got a really simple environment that you can see. It's just basically a little set of hallways, just so that I have shapes to have the electrical effect strike, arc, move around, things like that. And then I've got this electrical bomb blueprint that I created. And if I drop it in the scene, it's got a couple of settings that you can see over in the details panel. And then it's got some indicators around the blueprint placed on the level that show me the state of it. So I have the inner radius for the light. You can see the light hitting the floor here. The light is actually tied to the color of the lightning, so I can see even before anything happens what the color is going to be. The sphere, the yellow one here, is the radius of the total effect. So if I change this arc radius, you can see the sphere of influence expands and contracts. And what this is doing is basically giving me an indicator as to how far the initial strikes will go. And there's a reason I use initial strikes in that context. So without too much explanation, I'm going to go ahead and run it and let people see what it's actually doing, and then I'll talk about some of the methods behind it. So essentially, it's doing random traces in a direction, finding the endpoint, and creating this spline between it. And then I'm changing the properties to give that much more kind of undulating, alive electrical arc effect. And the way I did that, drop out of Simulate here, this is my spawning blueprint. You can see it here. If I open that up, it not only has a couple of very simple things in the scene for my kind of core indicator that shows me where the electrical arcs will spawn. The color picker drives that, so whatever color lightning I choose, that's what's going to come off. And then in the construction script, I'm doing really simple stuff. I'm basically just taking those values, like the radius, and setting up the preview object so I can see what the radius is going to be, what the point light color will be, creating some instances and things like that. In the event graph, more of the setup for the effect happens, but the fun part is that the effect itself isn't happening in this blueprint at all. This is more of a handler. So that's almost the entirety of the blueprint for this electrical bomb. It has an arc function that can be called as a custom event. There's some simple data that's passed in, and then once that blueprint is spawned, because I'm actually spawning a blueprint of type spawned arc, I actually pass in a struct that I call on that blueprint. So I have a function here that's called on that spawned arc that's passing in all the data. How far did the radius allow it to strike? What user settings are being passed in? And all of that stuff is contained in this arc values struct. So I created the struct and populated it. So these are all the things that the blueprint needs to know about when it creates this electrical system. And some of it is simple, like distance and color. And then there's some behavior for branching, how many times it can branch, whether or not it's going to branch, whether or not the current arc that's being executed is a branch, things like that. And you'll see where these things get used in a few minutes. So once I create it in step one, and then I pass down the data that I want to set up, and then in that same event, I also trigger it. So I call spawn on the electrical arc as I pass in all of the data it needs. And then it goes and does a loop that says sometime in between the min and max random number of seconds, call yourself again. So all it's really doing is just looping through as the arc succeed, or as the behavior executes, calls another arc. The arcs themselves do traces. If the trace fails, it just kills itself and lets the next arc queue itself up. So if you place it somewhere like floating in the sky and it can only hit a few places on the ground, it may be attempting to create arcs and just early rejecting because the trace failed. So again, once this plays, you can see the arcs occurring, and there would be more arcs, but some of them are failing. They're going up into the sky or something like that. If I stop this and modify the settings, so let me say we'll change the minimum and maximum time that it spawns arcs down a bit, and now it'll try and spawn arcs much more frequently, which is probably also getting louder. But it does show that you can modify those behaviors. There's also this concept of branching, and it's not the traditional lightning branch where you have it fork as it moves. It's more of the arc hits something, and then we decide whether or not the arc should jump and continue. I'm going to go ahead and move this back into this little hallway here. So my arc here is pretty well contained. If I run it, get it where I want it, I'll set it back to, let's go anywhere from a half a second to a second. And now it's much more likely to succeed. There's no real fail direction. So my arcs are just going to spawn, hit the wall, and then kill themselves. But if I increase the branch count, I'll back around the corner, and when I play, some of these arcs that are happening are actually continuations. So essentially it creates the arc, stores the points that the arc hits, and then on the loop through, instead of going and creating an all new arc from scratch, it says, I'm going to use this data I already have and create another copy of myself. So it's creating children of the arcs. And I'm going to pull up the other blueprint, the one that gets spawned, and walk through that a bit. So we've got the construction script, which there's absolutely nothing happening. You can't even see anything in the viewport. It's completely default. Everything happens in the event graph. So we have on spawn, that function that I was calling in the handler blueprint. It grabs the struct that I created and passed in, and then it basically populates all of these variables. So I break that struct apart in a ridiculous sequence just so I could make everything pretty flat. Break this open. I could just as easily just handle the struct everywhere I wanted, but because I use the variables in so many different places, for my own peace of mind, it was easier if I just store all those values, because very few of them actually get changed once the spawn is passed in. And then I begin passing all this data through and looking to see, is this a custom position, which is derived from another set of things. And then it just starts going, it finds the arc endpoints. So this is where we actually do the trace. The trace is really simple. The default behavior is spherical. So I take the radius, I create a vector from wherever the actor's location is out along X, and then I rotate that. So you have a trace that basically gets rotated to some random orientation. I check to see if that trace succeeds. If it does, then I pass the data along. So if it hits, it gets set. It then stores all these values that get used later on. And here we have just some collapse graphs for each of the, like creating the spline itself, which is pretty simple. I actually pass the data down to the spline for its shape a little later. And then things like create the audio for the electrical point light at the destination. And then here's where things are a little bit messier, but here's where all of those locations are combined to make that final behavior. So essentially, I'm getting the location that it gets hit, the traces on both ends. I get the normal for where it hit. So if you hit on a sloped plane, you'll actually get the arc coming off as if it struck it at the right orientation. It also gives me the orientation to spawn the particles so that the sparks go off in the right direction. And then this gets passed into the set start and end for that spline. So this is where the spline is created, and then all of its tangents are set and its endpoints. I then create the particles at the endpoint, and then this sets the direction of the spline with ladder up. The whole idea for the arcs was, if you're familiar with a Jacob's ladder, it is an arc between 2 points, usually something that looks like bunny ears, antenna, or something like that. When that arc is created, it heats the air. The hot air is an easier channel for the electricity, so as the hot air rises, the arc will rise to kind of stay in that hot spot. So I wanted to get something a little like that, in that as the electrical effect ages, it starts to bend upwards and break up. And that's where this bias vector is actually passed into the material on the arc. And I'll talk a bit about the material in a bit. And then there's logic that says, is this a branch? If it is, we need to do things a little differently. If it's not, we check to see if I should be let it move. And I'll show that in a second. And then we finish. And the finish is kind of interesting because it's essentially a timeline that controls the age of the effect. So as the effect wants to dissipate, this curve is in play, and that handles the arc kind of losing coherence and breaking up. We have the rise, which is the Jacob's laddering I was talking about. So you'll notice it's not linear. I customized the curve to get a specific look. And then we have starting the arc where it first joins and has a little bit of noise there. And then the actual event that kills it. So here we have light kill. And what that does is that gets rid of the light at the end of the arc and also deactivates the particles. Make sure that if it is set to be movable, it turns that off, and then closes any further updates so the light on the system doesn't get updated. And then when the timeline's finished, I just destroy myself. One interesting thing to note, I ran into this with the particles. If you create a component and give it the emitter template, you will kill the particles when you call destroy actor. All the particles will vanish because the component that's storing all that would be part of this actor. So if I kill this actor, all the components go away. So what I did instead was I spawn an emitter at the location, whatever that location may be. If it's a custom position, again, I'll talk about that later. I use that. Otherwise, I just use the regular endpoint. And what this means is that since this is spawning an actor instead of creating a component, if I destroy the arc and the particles aren't done, the particles have a chance to complete themselves, whether it's still spawning new particles or the ones that already exist are bouncing around. Those get to die, and then I can call activate and deactivate on this because I've made it a variable itself. So the behavior I was talking about with the material, where I'm passing these values in. If I go into my electrical noise material, so this is what gets put on those arcs. There's a couple of things going away. One, I have opacity masking with some noise, and that gives me a noise pattern. As the material gets old, because of the timeline, it breaks up in kind of this noise pattern. And that's combined with the eat away masking, which is kind of a moving noise pattern. Looks like this. And all of that ends up kind of summing up the overall material effect of it etching away. Here's that Jacob's ladder displacing, so I can pass in a bias vector, which is the normal, basically the world vector that I want to move this whole effect along. And then here we've got something you should not do. And the reason I say that is because I'm using actual 3D noise inside of my material, which looks really nice from a preview perspective, but it can add a lot more instructions to the shader. What I will eventually end up doing is replacing these with just noise textures, two-dimensional ones that I pan in the appropriate coordinate space and put back together. But for prototyping, it was easy to do this and quick with just the noise. And I am using fast gradient, so while it doesn't save me a ton of instructions, I am only doing 73, even with all of this behavior, mostly because it's really simple math that's being invoked here, and only a couple textures. Most of it is done just right here in this noise behavior. And that gives me the arc curling. Oops. Trying to get this off screen. There. So if I turn off my branches and move this back out where we can all see it, if I simulate, that curling, all that noise behavior, is coming from that material. It's not being passed in the blueprint. It's not an inherent part of the spline mesh component. It's purely the material being forced to displace the vertices. I actually exposed some values for how strong the noise is. So if I increase the noise scale dramatically, like 5,000. So here's what they would look like with basically just the material behavior kind of removed. So I would end up with kind of long warping splines. As I bring this noise scale down, I start to get that much more alive electrical flow. It almost looks like it's finding its way through a liquid or something like that. And then the noise speed controls how quickly that changes. So now I'm getting a lot of noise, but I'm not getting a lot of motion after the noise is created. So this allows me to really kind of tune towards any given effect within kind of the electrical gamut. And then, of course, I've got things like being able to make the core visible. So if you just wanted to have it come from a nondescript point source, you can do that really easily. I also added, and this is post, well, actually in the last week, I gave a variation of this demonstration when I was in Montreal a couple weeks ago. I couldn't leave it alone. I came back and I kind of kept working on it. And so one thing I wanted to do was I wanted to be able to have an arc not just go from like the center out, like it is here. I wanted to also be able to go from point to point. So I actually added a drop-down that lets you select point-to-point behavior. Now, by default, this goes from the two vectors. So if I select these, there's my destination, here's my origin. So now I will get arcs between those 2 points. So I can now set up an arc between electrical towers or from a generator to a specific thing. I can even go in and let me find a good piece of mesh here. We'll go ahead and add 2. So now inside of my spawning blueprint, I can choose that instead of vectors, I'm going to use object endpoints. And I've exposed an origin object and a destination object. Now this, I haven't had as much time to debug this, so there's a little more likelihood that I can get something wrong, but we'll see. Yeah, so my start point isn't getting the correct object. But you can see I'm striking this object wherever it is. If I convert this to movable, play again, you can see as new beams are created, they automatically strike that object wherever it goes. I could make that object conceivably the player and have this thing hit the player wherever he goes. So all this kind of stuff, yeah, go away. Doesn't like something I did. All of this is designed to be really versatile. I wanted this to be essentially a system, a tool for adding that kind of electrical arc behavior to your scene. And so using blueprints to kind of inform the other systems made that really, really feasible. So here we are, just the two endpoint vectors again. And of course we can change that back to random spherical. And we'll just strike anywhere. So there's one thing that I try to avoid at all costs, and this is not uncommon, I think, for designers, and it's certainly something we try and speak to quite often, is avoiding using tick wherever you can. I have to, because of the way I set this up in one particular point, if I can remember where the heck I left it. Here we are. So there's dynamic updating, which means if I set this flag of movable, and we'll leave the core visible, and reduce the spawn minimum, and let's give it just a couple of branches. So now if I select this and move it, you can see my arcs bend to reach the core again. So as I move this, and it spawns, my arcs are updating my position as I move through the world. That's because of this movable flag. Now, in that movable flag, I'm checking to see, is it movable? And that calls set moving, which opens this gate. And now tick, which has been gated in a couple different ways. Of should I allow any tick? Is it time to die? Do I use a custom position? As long as these pass the various tests, the gates open and tick can now flow through and set the start and end point for that spline every tick. Now, there's a number of different ways to do this. Tick is the highest cost. I could instead do it in an interpolated way where I only spawn every X number of seconds and I interpolate the current position with the old position, so the arcs wouldn't be quite as smooth, but they would still strike the right things. I haven't bothered to go in and set that up yet, but it is a valid way of reducing some of the cost, because what I've got here is something I'd prefer to update before we actually used it in a production project, whether it's game or demonstration or whatever. But a lot of this is set up so that if the effect were, say, centered on the player, I'm charged up or imbued with electricity, I could run through the world and have this like skirt or sphere of electrical arcs striking everything nearby, and it would be a much more dramatic effect than just having it on some piece of broken electrical equipment in the world. So this makes it much easier for me to set up that moving behavior and then just try and manage the tick so that they don't happen too often. I could set it up so that branches automatically don't update. Since their source point doesn't change, you only really care about movement of the original object, the core piece that's jumping around. So these kind of things are pretty useful to be aware of. So going back into the spawned arc, you can see I've got a couple places where I switch based on whether or not the custom position is set. And that's, I basically look to see whether or not the style is something other than the random spherical. If it is, then I know that I'm driving the endpoint locations from the blueprint settings, not just from wherever the endpoint happens to reach. So somebody had a suggestion of having sparks on both sides, impact decals or burn marks, and breaking the electrical arcs from the center. So I have because this originally started life as just the center out, I could very easily add sparks coming from the center, or I could have it so that sparks only happen on both ends if you're doing something that is non-random spherical. So that way you could easily set it up so that if you do want them from the center out like this, the sparks only happen at the destination points. With the branches, that kind of fixes itself because the beginning of one branch is always the end of the previous arc, which the end of the previous arc should usually have a set of sparks attached. In terms of doing things like decals, there's no reason I couldn't, and the engine certainly supports it. It was much more of a, here's where I got in this period of time, and again, since I am creating a lot of content here on the fly, limiting the complexity of that where it makes sense is valuable. If you notice, there's not usually more than 5 or 6 arcs alive. You can actually watch the world outliner to see, like, it's spawning and deleting them as quickly as it can, because I don't want them laying around, consuming CPU cycles, having functions called on them, being potentially more expensive. And in terms of breaking the electrical arcs from the center, they actually do break from the center. That part of what they do is, as they Jacob's ladder, and this happens very quickly, and it's not always easy to see, is that the material actually prefers to lose opacity from the center to the ends, so that you still have that kind of charged plasma attempting to cross the connection, but it can't always quite do it, and that's handled inside of the let's see, inside of the nope, not in create particles. It is inside of finish arcs. The countdown passes out the curves for starting the arc, raising the arc, and dissipate, and that's informing the material on the arc to control the opacity, the arc value, and the dissipation. So a lot of that behavior is already encoded. It may need more tweaking to get the visual style that you're looking for, but it does work for me. Somebody asked, what are all the options that you can enable or disable in the material editor to keep the base instructions as low as possible as a base? The most important thing to note is using static switches inside the material can be really useful. So a lot of our more complex materials, and this is not an example of that, this is very direct and special case, we would have behavior like, say, the 3D noise behind what we call a static switch parameter. So what this does is, if I'll put here, give it a name like use 3D noise. If it's true, if this value is true, either by default it compiles the direction or the HLSL code differently. So if it's set to true, it will use the 3D noise on the final output. If it's set to false, which you can't really see because all of this is being dialed down to 0 inside of the material editor. There's a tiny little bit of pixel noise going on, but you can't see it very well. When I turn it off, this border of the material has become extremely simple. So you can see the number of instructions looks like it's not updating correctly in the material editor. But having your expensive things that you don't always need behind switches like this, if the switch is turned off, it compiles the shader completely different. It's not just a matter of the end result looks different. It's actually changing what HLSL instructions are compiled into the final shader and on the surface. So this is a really good way of choosing your battles in terms of where you're spending your performance time. If you don't want to have it on for one particular instance, this can be changed per instance and have all this stuff set up. So that's that. Other than that, most of it is lighting related or translucency in terms of increasing your cost dramatically. The most performant material is unlit, opaque, because then the material doesn't receive lighting. It doesn't have to be sorted unusually. It doesn't have to be blended against the rest of the scene. It's just rendering solid pixels wherever they happen to appear. And then, of course, going through and changing the shader model. All of these have different kind of core compiled shaders that go along with them for supporting things like hair or skin, clear coat, stuff like that. So the base shader cost will change based on which shading model and what material domain you choose. So there's a lot of documentation on this on UDN. So if you have any deeper questions about that, I invite you to go and check that out. Somebody asked me to explain on a technical level what the responsive AA option for particle materials actually does. So my understanding is that the way the temporal anti-aliasing works, it is less likely to eliminate small pixels if responsive AA is turned on. However, it's a little more expensive to render the shader, and it can affect temporal anti-aliasing for other surfaces. It's generally best to do for like small sparks, things like that. Don't use it for large surfaces. Can I dynamically control particle emitter spawn points or density on faces of a mesh using a material? No, there's no way to currently pass in material properties to a particle system in a way that can control the spawning. If you think of it as like, I have a sheet of paper, and as the sheet of paper burns, I want sparks to come off of only the burning edge. There's no efficient way of doing that using the particle systems now. Normally what we would do is we would have some combination of effects, some particles, some vertex deformation, so that as the paper burns, it appears to break up, and then the particle systems are just kind of moved at the right time, things like that. Somebody asked me if will the origin scale, and or can you show the origin sphere close-up or scaled? I'm not exactly sure what they're asking here. I mean, the origin sphere itself is, I mean, I can scale it up. It's likely going to pass some of those scaled values. Yeah, you can see. Because I've scaled this, the first arc is receiving that scale, but the other ones won't. So the children are going to be oddly short, and my guess is the parent arc is probably going too long because the trace is the results of the trace, the vector that's being created, is being scaled as well. If I was going to make this support scale, I would much rather write it myself in the blueprint and then expose that, and not allow the transform scale to affect it as much. So select this and set the scale back to 1, and now all my behavior should be correct again. And of course, yeah, I can change behavior, and this is kind of fun. So currently I have the kind of white-blue. As I change it, new particles or new arcs that are created will be created with the new color. So I can get very much kind of a Terminator-esque blue electricity, modify the scale a bit of the noise and things like that to smooth it out a bit. It's not quite so noisy. And play around with it. Knowing that in a usual scenario this would be client-side, what would be a good approach to sync this in multiplayer so every player sees the same arc? Would become important when the arcs can, for example, damage players. So there's two things. One, if this was being done in a multiplayer setting, the arcs themselves would purely be visual. What we would likely do is set it up so that this doesn't automatically spawn the arcs. We give it a destination because another event is occurring, because somebody is being shot by it or electrocuted or whatever, and then we would spawn a specific arc between those 2 points. Either pick a random point within the bounds of the player, or pick a bone or something like that, and spawn it. So games, client side, you're seeing the arc. Server side, it's just registering that a damage event of type electrical arc has occurred, and it relies on the client to show the results. Now, if you had a situation where the arc could damage someone as they walk through it, then you would have to do something a little different. You'd have to do the traces on the server and interrupt, basically have the trace be somewhat continuous until the arc is done. The arc couldn't have quite as much noise because, again, if you have an arc that is curling and bending for a large amount, you wouldn't necessarily be able to do a straight trace and kind of intercept that. But that would be how we would kind of replicate that event and that behavior across the network. Somebody, Naked Gamma, asked, line trace or sphere trace? I'm using a line trace. I haven't actually played with sphere trace much, so it was easier for me since I'm doing occasional traces and I only want a single endpoint to just do a line trace really cheaply and use the results. There's probably a number of other ways this could be done. This is the one that I chose just because that's what I'm most familiar with. You can also do things, depending on the setup for content in your project. If I take, say, just a sphere and put it here, inside of the sphere's properties, I'm going to allow CPU access. And then I think, if I remember right, this only works on one particular setting, but I'm going to set it to point to point. I'm going to set it as the origin object. Get it? Yeah. And then, yeah, I don't think I had that working when we set this as the destination. Again, because I've been expanding this, there's things that aren't quite working correctly. This is acting like it's, oh. Somehow it got its old scale back. So what I'm doing is, in my behavior for the spawned arc, it knows that if it's set to an endpoint as a mesh, and again, I think this only works if the origin is do this way. So now I'm going to tell it to use object as endpoints. Yeah, that doesn't work either. Fantastic. So basically, there's functions inside the Blueprint library for being able to retrieve the actual mesh endpoint and get a specific. Where did I put it? I don't remember where I put this behavior. But you can actually get the vertices inside of. I wonder if I left it in. I might have removed it. But you can, if that allows CPU access flag is on. This means that in Blueprint, you can actually get the vertex locations. You basically get an array of all the verts inside of the mesh. And then I had it set up to randomly get one of those vertices and pass that in. But it looks like, yeah, I've just zeroed it out if that was the case and removed that behavior. But you can basically set it up so that if that flag is true, then you can strike a given point on the surface, or a given vertex. It doesn't give you the face normals or anything like that, but it does mean you could spawn a particle system from a vert or use it as an endpoint, things like that. A question just to have it as sub-arcs, like not the separate arcs you have now, but as in little arms that stick from arcs without touching any surface, like what happens with lightning. That would actually be not terribly difficult with a bit of a modification to the material. So if instead of doing it as a spline between 2 points, where I have to know both points, I would probably have just a section of static mesh that was this, basically just the placeholder for what the arc is going to be, and then spawn that from some point along the spline, and as long as the same material settings for displacement are applied to that secondary mesh, it should have the same vertex offsets, and as long as the scale is the same, you would get tendrils coming off that could live some amount of time, and you could get the kind of lightning fork instead of just a continuous arc that strikes and then bounces. Somebody asked if I can constrain where the arc's endpoint hit to certain materials, like metallic materials and not insulators. Yes, as long as certain conditions are true. I mean, you can get the material that's on, like, especially since in this case, I'm explicitly telling it that my endpoint should be a given object. If that endpoint object, because I could query it inside the blueprint, if it was aware of, or if I retrieve the material that's applied to there and say check it against the library of values, or look to see whether or not the material has, say, a metallic value of greater than 0.5 or something like that, then I could consider it to be conductive, and it would be a valid thing to spawn from. Right now, it really doesn't look at anything more complicated than an endpoint, but that is something that could pretty easily be extended. I wouldn't want to go too far with it unless there was a very game-specific reason, just because increasing the complexity increases the amount of time it takes to debug. It increases the possible for performance costs of actually spawning these during gameplay. So it would be something that I would opt into in very specific circumstances, and potentially, just have it behind a Boolean inside the electrical bomb class itself that says, if you choose to check the endpoint materials and see whether or not it's metallic above a certain value. So the last thing I want to talk about the arcs and this kind of system as a whole has to do with the branches, or the continuing arcs. So when I spawn that arc here, I'm basically passing in, are you already branching, and is this whole system set up to allow branching, and how many branches, basically how many continuations of an arc am I supposed to allow? If these values fall within certain potentials, certain values, I basically do the same thing. I do another trace to see whether or not the new arc can go somewhere. And one interesting thing that I found was that if you look at the way the trace happens, right? We go from the destination and it happens to hit the ground. So now we're talking about basically having my starting point being like this. If I try to do that same spherical trace, fully half of those traces are going to hit the floor before they go anywhere. And so I'm going to get an arc that's going to try and do something interesting, but really only move for like an inch. So what I decided would make sense is that I trace to here, and so I store that data. So that's my initial arc. And then I move up a certain number of units and I trace again. And what that does is it gives me a little bit of headroom to trace out, not necessarily have a really high likelihood of hitting within a few inches of the same spot, but I'm not moving a ridiculous amount up. It's just like 50 units, which gives me just enough clearance that my arcs will tend to crawl across the world instead of kind of tripping and stumbling and just zapping the ground a whole bunch in one spot. So that was a pretty important thing. The other thing is every time I branch, it decrements this branch count and says you can do it one fewer. And then I also maximize this again. So I spawn it again, but the only thing I pass in that's really different, because I'm passing that struct again, is I'm got this play rate and I'm increasing it by 15% every time. So what happens is you have your primary arc that runs at a play speed of 1, that timeline that tells it when to dissipate. Its children, the arcs that are created from that, run faster and faster for each child. The idea was that to get it proportionally fast enough so that one arc seemed to kind of die when the source connection was lost. So, you go from electrical generator, you bounce across a whole bunch of parts in the world, and then that lightning arc all kind of dies at once instead of having it crawl as if it were now alive and yet disconnected from its parent. I could easily set that to be the other way and have it take longer, but let me get rid of some of these and drop an all new electrical bomb in. Let's change this color to green just for fun. And let's set the branch count to something like ridiculous. So now as branches occur, even though it can kind of run away a bit, it's not as likely to. Move this here. So now you can see the, even though there's a lot of branches being created, and you can see that it's making its way around a large percentage of the scene, that continuous arc tends to die off about the same time. And this is kind of a trial and error thing. My guess is there's probably some proportional relationship between the length of the trace that succeeded and the speed at which its children should die. But I found that about 15% worked pretty well for the case that I was in. And that kind of inherited behavior where subsequent children have a very different perspective on their own lifetime actually went a long ways towards making the arcs and the continuity of the system feel a little more physically rational, even if not completely accurate. Somebody asked, what is the most limiting factor of this blueprint? It's pretty much a framework. There's not a lot of limitations that are directly due to the blueprint structure itself. I actually very much like the fact that I have a handler blueprint that can be self-limiting in terms of how extensive the impact it has is. If I reduce the number of arcs or reduce the radius, increase the time between loops, and reduce the number of branches, you can end up with something that is pretty simple, right? It spawns an arc occasionally. It doesn't do anything particularly expensive, and yet a duplicate of it right next to it could be doing a ridiculous amount of electricity arcing all over the world. So I really like the way that worked. That said, every time I open this up, the potential of, I could handle this case or this case, it just keeps expanding. I keep finding new things that I could kind of do and play with. And some of that is, since I moved to this struct method, it makes it really easily extensible, right? I can modify, as long as I don't eliminate chunks of the struct that I'm already using. If I decide there's more data I need to track or pass between parent and child, I can do that, and I don't even have to do anything in my blueprint if I don't need to, right? I can say, I'm going to track a decay color. So over time, the electrical potential decreases, and so your arcs aren't as strong or whatever. I could easily add this and track that in the blueprint whenever I want, but know that the data is stored in the struct for whenever I need it. So there's some things about that I really like. Somebody asked, is there some way to tell if an arc fails, then make it create another so the effect is more consistent? Actually, I do. Inside of the electrical bomb itself, there's the trace behavior, which is somewhere in here. I love how I'm just looking around my own blueprint. Do I not do it until... Maybe I do it in the other blueprint. Anyway, I know if the blueprint fails, and I can then spawn it. Oh yeah. So basically I say, trace to see whether or not I can get from my parent location to my new my new destination, and then if that fails, if the trace hit fails, I can just destroy the actor immediately. I don't have to go through the rest of this behavior, and you can actually see that happen a little bit. Get rid of the branch count here and reduce this a little bit. Would help if I was not still simulating. All right. So if I move this far enough away that the radius doesn't intersect much and hit play, I can watch it immediately create deleted actors occasionally because it's spawning it and then immediately finding that it failed. There's nothing to say that I couldn't just as easily say you failed, so immediately try again. But right now it's set up so that if it does fail, it just jumps back up and hits the, oh, here's the trace and getting the section from stack meshes and stuff. Basically, I just look at it. If you failed, just try again on your next cycle. I could just as easily set that up to do another trace until it succeeds, but I don't like that kind of blocking logic where you expect to force it. It's because you could end up with a runaway case where it fails a whole bunch, and then suddenly your blueprint is executing a bunch of function calls repeatedly for no benefit. I would much rather have it acceptably fail unless I'm in a specific case where I want it to explicitly succeed. Again, like the gameplay behavior where, hey, I have to hit this player because I'm doing damage to him, spawn it between origin and destination, destination being the player, ignore everything else that's happening, which is how a lot of weapon behavior works. We know we're going to hurt the player needs to see, and other players need to see, so we kind of break the rules of when the effect should work in favor of showing the players what's actually happening. So I think that pretty well wraps it up. I'm just going to dump a couple of these out into the world for fun and let them run rampant, just because I enjoy it. Just give them all a bit of a branch count and let them run. There we go. Move this guy a little further in so he can actually hit some stuff. So that's my discussion about the electrical arc blueprint that I was working on for fun. Hopefully people found it interesting and answered some of the questions that came through. And I'm sure we'll be talking about this more in the future. Thanks a lot and have a nice day.